Hello, welcome to Learn with Lakineni. So in this session, I'm going to explain the language fundamentals. So any programming language, if you want to learn, first of all, you need to know the constructs of the language, the fundamentals of the language. So in the coming 2-3 sessions, I'm going to explain you the complete language fundamentals. So you please go through the video clearly and understand and write the notes, and you please prepare so that it will be helpful for you. So before watching my video, all of you please subscribe to my channel, Learn with Lakineni. Please subscribe, share and like so that you'll get more updates from my channel, Learn with Lakineni. Thank you. Please watch the video. Don't forget to subscribe.
Array, range, list, tuple, set, frozen set, dictionary, none. So these are the 14 data types in Python. Okay. Now I'll go with the live code running, and I'll explain you what is the integer and what are the different characteristics of integer and everything. So today we'll discuss about integer. These 14 data types takes 14 classes for explanation and for practice. So are you able to view the screen? See here, the first data type is integer. So here, unless like C, Java, some C++, you have different types of integers. Int, short int, long int, long int. These are the different types of integers are there in other languages. But Python doesn't have that many languages. Python have only one type of number system, that is called as integer. It doesn't mean that whether you store a small integer or whether you store a bigger integer or whether you store a long integer. There is no such type of questionnaire in Python. Only number system. Any number, it may be a positive number or it may be a negative number, you can store in Python as an integer. Okay. Suppose if you see, suppose if you write a is equal to 10. So I have not declared a is any type. I am not declaring any type because I don't bother about what type of 10 is. Python has a capacity to take any variable in any value into the variable, and it can check what type of data it is when it is at the time of compilation. So here I have taken a is equal to 10. I don't know what type of value 10 is. So simply I am running the value. Here I am writing type of a. So when I am running the type of a, it shows integer. That means you are not declared a is equal to 10 as an integer type. But Python knows that you have given an integer value. Okay. So here a is equal to 10 I have given, and now I am asking what type of value I have stored. Python, do you know what type of value I have stored? Yes, Python is answering. Yes, I know. You have stored an integer type of value. Suppose if I take b is equal to some large value. I have taken some source of value. I don't know what is the size of the value it is, but I have stored. Suppose if you ask Python, can you say what type of value you have stored? Yes, Python is saying you are storing an integer type value. I have stored a is equal to a small value. I have stored some lakhs of values in B. Then also it is taking as integer. So there is no range or specific range in Python. That means from small integer, long integer, or short integer. There is no such segregation. There is no such differentiation in Python. You have only one type of characteristics, one type of range, that is an integer. It may be a small value or it may be a bigger value. I think you have seen the value of a is equal to 10 and the type of a, and the value of b is equal to some value and the type of b. Okay, so both it is showing it as a integer type. Next, suppose suppose if you want to see the address of a, similarly in C language, Java language, every memory has an address. You are storing some value 10 in A, but it has some address in the memory location. So if you want to see that address of the memory location, you can simply type ID of A. ID is a function which shows the address of a particular variable. So here the address of the variable is shown. Suppose if you want to show, you want to see the value of the address of B, you just simply write ID of B and just execute it. So it is showing the address of B also. Okay. Another biggest advantage in Python and most fascinating characteristic of integers in Python is, suppose if I write A is equal to 10 and B is equal to 10. That means I have stored the 10 value in A and I have also stored 10 value in B. In C language, suppose if you write A is equal to 10 and B is equal to 10, A is equal to 10 and B is equal to 10, then C compiler will take two memory places. For A is separate and B is separate. It takes a separate memory location for A for 10. It takes a separate location for B, and it stores 10 in B and 10 in A. But when we come to the Python, if two variables are having the same value, your Python interpreter will never give two different memory locations. It gives only one memory location, and these A and B will be referred to the memory location, to the same memory location. Okay, we just will see. Suppose if I want to see the address of A, the address of A is it has given some 140 something 1984. In the same manner, I want to see the address of B, and I'm running. You can see on the screen both addresses are same. The address of A and the address of B both are same. How it is possible? That is possible with Python only. Why? Because whenever two variables are having the same value, Python doesn't waste two memory locations to save the same value. So it shares the same location to both the values, both the variables A and B. So that's why A is showing the same memory location and B is showing the same memory location. That is the biggest advantage of Python. So when variables are having the same value, Python will never create different memory locations. It will create only one memory location. That memory location will be shared to all the variables which are having the same value. Suppose if I write C is equal to 10, again I have taken another variable C is equal to 10. Now I want to see the address of C. So address of C will be same. That means the address of A, the address of B, the address of C are also pointing to the same memory location, which is having the shareable value, which is called as 10. So that is the importance of Python integers. Okay. That means suppose A is equal to 10, B is equal to 10, C is equal to 10. So C is equal to 10. So how many variables are there? There are three variables. A is having the value 10, B is having the value 10, C is having the value 10. So these three variables are having the same value. So in Python, it creates first object. What type of object is? It is when it is compiling, it recognizes 10 as an integer object. So it creates an integer object. In that integer object, it stores the value 10. So now an integer object reference A will be allocated to this memory location. Again, you are creating the same value. B is equal to 10. Again, it creates a reference B. That reference will be linked to the object 10. Again, you have created C is equal to 10. So again, a reference C will be created. The reference will be linked to the object 10. That means C, A, B, C are all sharing the same memory location, so that you are optimizing the memory location. Instead of using three memory locations for the same value, you are using the same location for the three variables. That is the advantage and optimize the memory of Python concepts. Okay, suppose you may ask question, sir, suppose if b is equal to, sir, suppose what happens, b is equal to b plus 1. If b is equal to b plus 1 means the value of b is equal to 10 and plus 1. So what happens? It is equal to 11. Okay, so that means this 10 value will be erased and 11 will be stored. If it happens, then a will lose the value 10 and b will lose the value 10. So whenever a variable requires a change, immediately a new object will be created. In that 11 will be stored and this 10 will be cut. This link will be cut here and b will be referenced to the new object 11. Now in the same manner, a will be referenced to the 10 here and b will be referenced to the 10 here. So c will be referenced to 10 here. That means a and c are referenced to the same old 10 value, and b, whenever b is updating its value, a new memory location will be created. In that memory location, the value 11 will be stored. So this is the concepts behind integer. I think, are you able to understand? Hello?
Yes, sir.
Are you able to see the screen?
Yes,
Yes,
sir.
sir.
No, I am writing. I'm sharing. Are you able to see the screen? Suppose if I
Yes,
write
sir.
b is equal to b plus 1. B is equal to b plus 1. Okay. So when b is equal to b plus 1, so what happens? I have updated the value of b. Now I will see the idea of b. The idea of b is completely changed. Have you observed the difference? The idea of previously the idea of b is some one thing. Last one is 1984. Here 2016. Okay. Now the idea of a, you just run it. It is showing the same. Now the idea of c, it is showing the same one. Okay. Are you getting or not? Hello?
Yes, sir.
So that's why whenever a variable showing to the memory location, it is updating, the updated value will be created in a new memory location and this reference will be linked to the new memory location. The old values referring by A and C will be shown as the same memory location. Okay. Hello. Are you getting or not?
Yes, sir. Yes, sir. Yes, sir.
Suppose if you want to see the type of how can you see the type of variable? You can see the type of A. The type of A is equal to integer. The type of
Integer.
B is equal to integer. The type of C is also integer. Okay. So if you want to see the type of an integer value, you can see with the help of a function called as type. If you want to see the address of a variable, you can see the address of a variable by using idea of C. Okay. So like this, you can use these memory locations, and you can use the type function, and you can use the address of a variable. Okay. Still people are coming and going. So are you understanding? Hello?
Yes, sir. Yes, sir.
Are you understanding?
Yes, sir.
Okay. Suppose if you want to store a float value, you don't need to know about whether you are storing float or not. Just you are simply storing suppose I am writing some k is equal to 12.35. Okay. So you don't know what type of value you have stored, but Python interpreter knows what type of value you have given. So suppose if I write the type of k and if I run a float, so what value you got?
Float.
You got float value. Okay. So you have not declared this is a type of float, but Python internally knows that you have stored a float value. Are you getting or not?
Yes, sir.
Okay. So now I told that a if you take a is equal to 10, b is equal to 10, so both values are same, so that both are sharing the same memory location. But this concept doesn't applicable to float type of values. Why? Because Python doesn't support float the values which are having the same float values having the same memory location. Suppose if I write some g is equal to 12.345. Suppose if I write g is equal to 12.345. Suppose if I write id of g, what is the id of g? Something lost in the last triple 40. Suppose if we write id of k, so id of k is different from id of g. Am I right or wrong?
Yes, sir.
Id of the value which you are storing in k is 12.345. The value which you have stored in g is 12.345. Both values are same, but both are not sharing the same memory location. They are sharing different memory location because Python doesn't support same memory location for the same float values. Why? Because there are large infinite number of float values. It cannot support those many numbers. That's why it doesn't. The concept is not applicable for float values. Okay. Okay.
Yes, sir.
Okay. Suppose again it is showing
Sir, I
that.
have a doubt.
Tell me.
సార్ ఇప్పుడు ఏ ఈక్వల్ టు 10 బి ఈక్వల్ టు 10 అని ఇచ్చారు కదా సార్, అలా కాకుండా ఏ ఈక్వల్స్ టు బి ఈక్వల్స్ టు 10 అని ఇస్తే తీసుకుంటే తీసుకోదా?
Yeah. A equal to
బి ఈక్వల్స్ టు 10.
A is equal to B is equal to 10. A is equal to B is equal to 10. Yes, it is taking. Now you can see ID of A. Now you can see ID of B. Now you can see ID of B. Both are same. Okay. So multiple assignments in a single line is possible with Python. That I will tell you when we go for operators concept. Okay. So anything is possible. So okay. Multiple. Suppose if you write suppose if you write A is equal to B is equal to, suppose A is equal to B is equal to C is equal to D is equal to 10. Okay. Then done. So happily it is taking it, instead of giving separately A is equal to 10, B is equal to 10, C is equal to 10, D is equal to 10. You can give the same value for all the variables at a time in a single line with the help of multiple variable assignment in a single line. Now, if you want to print the value of A will be 10. If you want to print the value of B, it will be printed. If you want to print the value of C, it will be printed. If you want to print the value of D, it will be printed. It is closed. Okay?
Okay.
Okay. So this is the concepts about integer and float. Still, there are many more concepts about integers and floats. Today, my number of sessions are closed. So that's why I'm stopping the session. Tomorrow I'll continue. Okay?
Okay, sir.
Okay. Thank you.
Sir. Thank you, sir.
Thank you, sir. Thank you, sir.
Okay. In the previous class, I have discussed about integer. So integer, there are no differentiation integers. Only one integer. That means entire number system you can put as an integer. That may be a small integer. That may be long integer, or that may be a negative number, or maybe a positive number. Anything you can keep it in a integer type. There is no differentiation. In Python 2, you have a differentiation. In Python 2, you have long integer and a short integer. But when it comes to the Python 3, it is completely eliminated. and there is only one integer called as int. Okay, have you seen the screen?
Yes, sir.
Okay. So in the last class, I told you one interesting concept that you suppose if a is equal to 10 and b is equal to 10, if you want to save the value of value of 10 in a and b, so how many memory locations you need in C language? You need two different memory locations. In Java, you need two different memory locations. But when it comes to the Python, how many memory locations you need? You need only one memory location. Why? Because Python is optimizing the memory location. That means instead of storing same two values in different memory locations, it is saving the same value at one object, that is called as integer object, in one memory location, and this a and b is referring to the same object to the same memory location. Okay, am I right or wrong? That I have shown that in screen also. Suppose a is equal to some 25. 20 have is my screen is shareable?
Yes, sir.
Are we able to see the screen? Jupyter notebook. Are you able to see the Jupyter notebook?
Yes, sir.
Okay. Here I'll tell you an interesting and excellent feature of Python, which nowhere can see this information from books or any other videos. Okay. Here I have stored a is equal 20, and also I'm storing b is equal 20. Okay. So what is the memory location of id? How to see the memory location of a? Memory location of a can be seen by using the function id. It is showing something 140 something something 1024. So in the same manner, what is the memory location of b? It is showing the same memory location. Why? Because when two integers two variables are having the same value, so that Python interpreter is saving the same value at one place, and the variables are referring to the same value. Isn't it? Till now, are you understand? Now see here. Just I'll do a miracle, a magic. Suppose C is equal to 500. C is equal to 500. Now D is equal to 500. Okay. Now can you anybody say what is the memory location of C and D? Are both are equal? The memory location of C can be seen as ID of C. ID of C means ID is a address function. So it is showing some 17390 something something. So the value of D also 500. So usually you people expect the address of D also will be same as the address of C. You see whether you get or not. So have you got the same memory location?
No.
Have you got the same memory location?
No.
Okay. Another magic I want to do. K is equal to some 255. K is equal to some 255. K J is equal to some 255. Now what is the address of is the address of I and J are same? So address of K is equal to some 1072 something. In the same manner, I want to see the address of I J also. So what is the address of them? Are both are same?
Yes.
The address of J, the address of K, and the address of J here same. But why the address of C and D are not same? C is equal to 500 and D is equal to 500. Both are sharing the same value, but their address are not same. But when it comes to K is equal to 255 and J is equal to 256, the address of K and the address of J are same, isn't it? Are you able to see? Here for the values of A and B, the addresses are same, but the values of C and D, the addresses are different. But for the values of K and J, the value is same, the address is also same. Then what makes the difference at C and D? At C and D. Suppose again I am taking some other value. M is equal to 256. M is equal to P is equal to 256. Then I compile. Now can you tell the address of M? See, this is all live running. Here I am running the code live. So here the address of M is equal to 14 something something 576 Now I want to see the address of P also. So the address of P also same. Am I right or wrong? But
Yes,
except
sir.
500, in all remaining cases the address are same. Then what happens with the 500? Why it is not showing the same address of 500? Suppose if I write JMP, suppose if we take W is equal to 557. W is equal to 257 I have taken. F is equal to 257 I have taken. Now tell me the ID of W. The address of W is equal to 1739 something something 5008. In the similar fashion, I want to see the address of I want to see the F also. What is the address of F? Both are same.
No.
The
No.
address of, the value of F and the value of W and F are same. 257, 257. Both are sharing the same value. But when it comes to the address, the values are different. The address values are different. The values are different. Here the important concept in Python is, in Python, when interpreter interprets or when interpreter runs, it automatically allocates some shareable memory locations from 0 to 256. All 0 to 256 memory locations are preserved and the same memory location will be allocated to the variables. Are you getting or not? When Python compiler runs, it automatically reserves some memory locations from the values 0 to 256. So whenever any variable using the values in between 0 to 256, that location will be shared. Above 256, it will show the different memory locations. So you can see here, for 257, the memory location is different. For 256, the memory locations are same. For 500 means it is above 256. That's why the memory location is different. When it comes to A is equal to 20 and B is equal to 20, so what happens? The memory locations are same because the value is in between 0 to 256. That means 0 to 256, including 0, 257. For 257 values, the memory locations are automatically allocated. So whenever any variable wants to store the values in between 0 to 257, so those already allocated memory locations will be shown. Why? Because the compiler designers, the programmer designers of Python thought that maximum programmers use the values in between 0 to 256. That's why those values from 0 to 256 are predefined and the memory locations are predefined. So any programmer wants to use the values in between 0 to 256, automatically the saved, the preserved, the already reserved memory locations will be allocated for the variables. I think you all got my point. Okay. So as an analysis, all the programmers thought that most of the programmers will use the numbers in between 0 to 256 frequently. So for those numbers, when compiler interprets, when compiler runs, when the Python compiler runs, it automatically allocates memory locations from 0 to 256. That's why if you allocate any value, if you allocate the values in between 0 to 256 to the variables, the same memory location will be shown for the same variables. Okay. So that is the most important concept of Python. So that's why when you want to see the memory location of variables having the same value in between 0 to 256, it will show the same memory location. If the value is more than 256, that means if A is equal to 500, B is equal to 500, definitely the memory location will be different. So that means the memory optimization concept will be applicable to only the values 0 to 256 only. About 256, that means from 257 onwards, if any number of variables having the same value, it doesn't show the same memory location. It doesn't share the same memory location. The memory locations will be different. This concept is applicable only for 0 to 256. The reason behind this concept is most of the programmers use the values in between 0 to 256. That's why when the Python interpreter runs, the values for 0 to 256 will be saved in particular locations. Those locations will be saved if any programmer wants to save their data from 0 to 256 in a variable. Okay? Are you getting?
Yes, sir.
Okay. I'll go into the next concept of integers. So integers can be represented in decimal format, binary. You can represent integer in 4 formats: decimal format, binary format, octal format, and hexadecimal format. In any of these formats, you can keep your number. Either you can keep your number in decimal format, you can keep your number in binary format, you can keep your number in octal format, you can keep your number in hexadecimal format. That means here you have several chances to store, several ways of here you have given, the programmer given several ways of storing his data in any of these 4 formats. You already know what is the decimal format. All the numbers by default will be in a decimal format only. So the decimal format digits are 0 to 9. Here there I have mentioned A is equal to 10, some B is equal to 1, 2, 3, 4, some C is equal to minus 3, 4, 5, 5. All these are decimal numbers. So these are usual numbers. Here you don't need to talk much about decimal numbers. We talk about binary, octal, and hexadecimal numbers. I already explained how to. See here. Suppose if I write A is equal to some 200, 2220. If I run and if I want to see the type of A, so the type of A is integer. Why? Because already all the decimal formats, decimal numbers will be in integer format only. So here we don't need to much discuss about decimal format. We'll go directly for the next format called as binary format. So this is a binary format. Binary form, this is base 2. You already know that the base 2 number is 0 or 1. That means any number can be represented in terms of 0 and 1. Okay. Binary number can be represented with a prefix 0 small b or 0 capital B. 0 small b or 0 capital B. So here I will show live example. You please listen. Here I will show many more examples on binary, octal, and hexadecimal. Suppose if I am taking A is equal to 0 small b, 0 small b, suppose 1101. That means here this 1101 is your binary number. Every binary number prefixed with 0b. Every binary number prefixed with 0b, where b indicates that your number is in the form of binary. That 0b, that b can be either small letter or capital letter. Both are same. That in Python, only one and only one place where there is no case sensitive applicable, that is either small b or capital B. For hexadecimal, either small x or capital X. For octadecimal, for small c, for small o or capital O. Where it doesn't consider whether it is a capital letter or a small letter. It is completely case sensitive free. So free from case sensitive. So A is equal to 0b 1101. So this is a way of representing the binary number. Suppose if I want to see, if I want to print the value of A, what is the value of A? I have given the value of A is equal to 0b 1101. That means I have given my value in terms of binary number. But when I want to print the value of A, it is showing in terms of an integer. In whatever format you store the value in a variable, But Python interpreter automatically converts that value into the integer type. When you want to print the value, it shows integer only. Actually, I have an intention to store my value in terms of a binary format. But if I want to see the value, Python interpreter will show in terms of integer only. Okay. Suppose b is equal to, I am writing, suppose g 0 capital B. You can use either small b or capital B. 0 b 1 1 1 1 0 0 1 0 1. That means that is my intention. I want to store my data in terms of binary format. Okay, you can store, no problem. But if you want to print, suppose if you want to print the value of b, the value of b will be shown in terms of integer only. That means automatically your binary number will be converted into integer number while the interpreter interprets the line. Okay. So how you will represent the binary number? Either 0 small b or 0 capital B. So either you can use either 0b or small b. Suppose if I write like this, a is equal to 10 some 10. I am representing the binary number 10101. Okay. Suppose if you print the value of a, it shows the same value only. Why? Because unless if you don't mention the prefix 0b, 0 small b or 0 capital B, it internally treats the number as an integer. So even though you are thinking that you are giving a binary value, it doesn't consider it as a binary value. Why? Because you have not prefixed with 0b or 0 small b or 0 capital B. So interpreter cannot recognize whether it is a binary number or ordinary integer number. So by default, your 10101 number will be taken as a integer number. So if you want to print the value of a, it shows the same integer value only. Suppose if I write instead of 1010b, if I write 0 capital B, if I run, suppose if I want to print the value of, a, so it is showing 21. In the previous example, it shows the 10101, but in this example, it shows only 21. That means the binary equivalent of 10101 is 21. Why interpreter recognize the number as a binary number? Because you have prefixed the number with 0b. So that's the information about binary number. That means you can represent your number in binary values also. Next, octal. You can represent your data in terms of octal. You already know that octal digits are from 0 to 7. Octal number can be represented with prefix value either 0 small o or 0 capital O. So there you can see the example. A is equal to 0 small o 1 2 3. So that means your interpreter recognizes that 1 2 3 is a number represented in octal form. How it recognizes? If there is a prefix 0 o. Okay, that O can be either small letter or capital letter. Okay. Now, suppose I want to say some k is equal to 0 O 1 2 3 4. 0 capital O 1 2 3 4. So I am running the number. Now I want to print the value of k. So now what is the value of k? Now it is also not showing the octal value. We have stored the octal value. 1 2 3 4 is an octal value. How you can say that it is an octal value? Before you prefixed the octal prefix 0 capital O or 0 small o. So that means you can store your octal number in a variable. But when Python interpreter interprets that value, it recognizes that you have given an octal value. Immediately that octal value will be converted into an integer value. When you want to print the value of k, in that integer decimal equivalent of that octal number will be printed. So the decimal equivalent of octal number of 1 2 3 4 is 668. So that value will be printed. Suppose if I take k is equal to 0 small, suppose some L is equal to 0 small o. If you write 5 6 something. So this is an octal number. Now I want to print the value. I want to print the value of L. It is showing 2419. That means the decimal equivalent of octal number will be printed. Who will convert this decimal octal number to decimal number? You don't need to convert. Python interpreter automatically converts. How it can convert? It recognizes with a prefix 0, O. Either the O may be capital letter or small letter. So it recognizes that the programmer or the user has given an octal number. It immediately the octal number will be converted into an integer number. That integer equivalent will be printed, or the decimal equivalent will be printed. I hope you have understood what is an octal number. Okay. Next, hexadecimal number. So you all know that hexadecimal number, the system is 0 to 9 and a small a to capital F. That means 0 to 15 will be represented as 0 to 9, and from 10 to 15 it will be represented as a to F. Here also you can use either capital A or small a. Those A to F can be used either it is free from case sensitive, so that you can use either capital letters or small letters. Suppose you can see here I have given some example. The hexadecimal number system can be prefixed with 0 small x or 0 capital X. So suppose if we take A is equal to 0 capital X, suppose 192 capital A. Then if you want to print the value of A, the value of A is equal to 6458. The Python interpreter recognizes that number as an hexadecimal number because of the prefix 0x. 0x x may be either small letter or capital letter. Immediately that hexadecimal number will be converted into an integer number. That integer value will be printed. So like that you can represent your integer value directly as a decimal number system, or you can store the value in binary number system, or you can store the value in octal number system, or you can store the value in hexadecimal number. But finally, when you want to print the value will be printed in terms of decimal format only. You have seen all the examples. Are you able to hear? Are you getting clarity?
Yes, sir.
Okay.
Yes, sir.
Okay. So like that, you can represent the number in any of these formats. Now another concept which I am going to discuss is you can convert from one number system to another number system easily. Suppose I have an integer number system. I want to see the number in binary number system. You have some functions bin, op, hex. These will convert one number system to the another system. All these I will explain with a live code. Just see. Suppose I have a number. A is equal to 124. So 1234. So this is what value it is? It is an integer value. Now I want to convert this integer value in terms of binary value. So simply use the function called as bin of A, then run. So now you can see the binary equivalent of 1234. A is equal to 1234. A is equal to 1234 is your number, integer number or decimal number. Now you want to see your decimal number in terms of an binary number. How can you convert your integer number or decimal number into a binary number? With the help of a function called as bin. Bin means binary. So bin of A is a value which you have given. So what happens? Bin of A is equal to, it gives some 0b. There you can observe in the output. So first it is prefixed with 0b. That means it is showing that the number after this is a binary number. The number after this is a binary number. Suppose I want to convert the value of A is equal to 1234 into octal number system. Then use OCT. Of A. Then compile. So you got the octal equivalent of your decimal number. What is your decimal number? 1234 is your decimal number. What is the octal equivalent? 002322 is your octal equivalent. That means you can convert from one system to the another system. Okay. Suppose for fun I am showing another one. See here. Already you know that the decimal equivalent of 1234 is some 0b. The binary equivalent of 1234 is 0b 100110100. Here I am copying this one and I am putting in octal value OCT. Then I am running. So what happens? That means the binary number can also be converted to octal number using the octal number system. OCT means octal function. whatever value you give in the octal function, it may be an integer, it may be a binary, and it may be hexadecimal. After function will convert this value into equivalent octal number. I think you are getting my point.
Yes,
No.
sir.
Okay. Suppose if I write the hexadecimal of A. So you got hexadecimal equivalent of A. A is a decimal value. What is the value of A? A is equal to 1, 2, 3, 4. So the octadecimal value is hexadecimal value is 0 hex 4D2. 0x indicates this is an hexadecimal system. Okay, are you getting my point? From anywhere to anywhere you can convert. Okay, suppose you take this hexadecimal number, you put it in binary number, that means you want to convert this hexadecimal number into binary format. Yes, you can convert. You got the same value. Here you got 0B something. So the same thing you got here. Okay. Suppose I want to convert some octal number 0x some E. Yes, you can convert that hexadecimal number into octal number system. That means it is showing some undefined 0A. Okay. We'll take this one as a hexadecimal and we'll put it in octal format. Then you run. So it is converting the hexadecimal number into the octal number. So in the same manner, from one number system to the other number system. Suppose if you want to convert an octal number into a decimal number, suppose you just write this is an octal number. Now you put that octal number into integer, then you convert. Yes, you got 1, 2, 3, 4 your original number. That means you have given your octal number into decimal number. You have converted your octal number into decimal number. How can you convert? By using the int function. So any number to convert into a decimal number, you have to use the int function. Any number system to convert into hexadecimal number, we have to use the function hex. Any number system to convert into octal number system, we have to use oct. Any number system to convert into binary number system, we have to use bin. Okay. So this is about the integer number system. Still now we are discussing about only integers. There are a lot of things to know about integers. So have you all understood the way of storing your values? You can store your value in 4 formats: directly in decimal format, or you can indirectly store it as a binary format, octal format, hexadecimal format. But your Python interpreter finally recognizes and considers it as a again only of type integer only. If you want to print the value, it prints only integer value only. And also you can convert from one number system to the another system. That means from integer to hexadecimal to octal to binary, from anywhere to anywhere you convert using the 4 functions called as int, bin, oct, hex. Okay. So binary number system can be shown with a prefix 0 small b or 0 capital B. Octal number can be shown with a 0 small o or 0 capital O. Hexadecimal number system can be shown with a prefix 0 small x or 0 capital X. Okay, so this is the information about your number system. Still so many concepts are there. So whatever I have explained, that all things information will be there in your PPT. Okay, I have explained you the base conversions. Okay, from bin to you can convert to binary, from binary to you can convert to bin, anywhere from anywhere to anywhere. The bin function, the oct function, the hexa function, and int function. So in the entire session I have explained the various forms of integer. So how can we convert an integer to a decimal? How can you convert an integer
into a hexadecimal, octal number system, binary number system, from one number system to another system. That means from octal to binary, from binary to octal, binary to hexadecimal, hexadecimal to octal. Like that, I have explained various functions with a predefined oct function, hexadecimal function, binary function. Okay. So in the entire session, I have explained about the first data type of Python in various ways. In the next session onwards, I am going to explain the remaining data types. So please watch my videos. Please subscribe to my channel, Learn with Lakineni, so that you will get more updates from our channel. Okay. Thank you.